Good morning everyone. Welcome to the next lecture. Today we will discuss about the determinants of a matrix. The determinant of a matrix is a fundamental concept in a linear algebra which is used to determine the several properties of matrix and its associated the system only a square matrix. See, the determinant of a square matrix, for example, say matrix A, typically denoted as it is determinant A or the absolute value of A, or simply we can say that it is A determinant. It is simply a scalar value that can be estimated from the matrix elements, and the computation is varies depending upon the size of matrix. The determinant of a 2 by 2 matrix is derived by taking the product of two elements on the principal diagonal and then subtract from it the product of two elements of the off principal diagonal. The determinant is specifically, it is defined only for a square matrix. Consider here we have a matrix A which is equal to A, B, C, D. We want to find out the determinant of a given matrix. Then how we will find? See here, we are going to multiply the elements on the principal diagonal, that is A into D. Then minus, then off principal diagonal elements we are going to multiply, that is C into B. So here the determinant value is equal to, it is A into D minus B into C. Or we can also say that if we have a matrix A is equal to A11, A12, A21, A22, we have a 2 by 2 matrix and we want to find out the determinant here. Then here we can find the determinant by multiplying, see, A11 into A22, that is we are going to take the product of the principal diagonal elements, subtracting here, that is the multiplication of the elements in the off principal diagonal, that is A12 into A21. So the resulting value will be equal to the determinant of that particular matrix. For example, see, matrix A is equal to 2, 5, 4, 3. We have a 2 by 2 matrix. So here we can find the determinant value of A, that is 2, 5, 4, 3. We are going to multiply here 2 into 3. 2 into 3 minus 4 into 5 or 5 into 4, which is equal to 2 into 3, which is equal to 6 minus 5 into 4, which is equal to 20. So which is equal to minus 14. So the determinant value of the given matrix A is equal to minus 14. Consider another example. We have a matrix A minus 2, minus 6, 4 and 12. 2 by 2 matrix we have, and we want to find out the determinant value. How we can find out? We are going to multiply the elements on the principal diagonal, that is minus 2 into 12 minus 4 into minus 6 or minus 6 into 4. See here, minus 2 into 12, which is equal to minus 24, minus 6 into 4, which is equal to minus 24. So minus minus will become plus. So it is minus 24 plus 24, which is equal to 0. So here the determinant value is equal to 0. Now if we have 3 by 3 order of matrix, then how we can find the determinant? See, for example, the determinant A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. We want to find out the determinant here. See, we start here with the first element, that is A11. Then we are going to cross the concerned row and column. Then what is remaining here? We have a submatrix 2 by 2 matrix, that is A22, A23, A32, A33. So here, considering the first element A11, crossing the concerned row and column, then the submatrix we are going to write here, that is A22, A23, A32, A33. Minus, we should put the minus sign here. Consider the second element, that is A12. We are written here A12 multiplied by deleting the concerned row and concerned column. See, A12 concerned row is this one first row and the second column. Then what is remaining here? A21, A23, A31, A33. We are written here. Plus, considering the third element, that is A13, then we are going to cancel down the third column and the first row because it is belongs to that particular row and column. The third element is belongs to that particular row and column. So it is what is remaining here, A21, A22, A31, A32. So I have written here. Now we can simply by take the determinant value of 2 by 2 matrix here. It will become, see the A11 into multiplying these two elements, that is A22 into A33 minus A23 into A32 minus second element, that is A12 into multiplying A21 A33 minus A23 A31 plus third element, that is A13 into A21 into A32 minus A22 into A31. If you go for simplifying it, then it will produce the determinant value of a 3 by 3 matrix. Consider one example. See, matrix A is equal to 3, 6, 5, 2, 1, 8, 7, 9, 1. We have a 3 by 3 matrix. We want to find out the determinant value here. So first we are going to write this particular matrix in this particular format. Consider the first element, that is A11, which is equal to 3 here. Then cancelling the first row and first column. Then what is remaining here? 1, 8, 9, 1. Minus, putting minus sign here. Then considering the second element, that is 6. Then we are going to cross the second row and second column. First row and second column. So it will be 2, 8 and 7, 1. Plus third element, that is 5. Now we are going to cross the first row and the third column. What is remaining? 2, 1, 7, 9. I have written here. Now we are going to consider the 3 into 1 into 1. See, 1 into 1 minus 8 into 9 minus 6 into 2 into 1 minus 7 into 8 or 8 into 7 plus 5 into 2 into 9 minus 1 into 7. So we are written here, and if you go for simplifying it, then it is equal to 3 into 1 into 1, which is equal to 1 minus 8 into 9, which is equal to minus 72, minus 6 into 2 into 1, which is equal to 2 minus 8 into 7, which is minus 56, plus 5 into 2 into 9 minus 1 into 7, which is equal to 7, 18 minus 7. If you go for simplifying it, it is equal to minus 213 plus 324 plus 55, which is equal to 166. So the determinant value here, it is 166. Now consider another one. We have a given matrix A. It is a 3 by 3 matrix. We want to find out the determinant value of this given matrix. See here, we have taken the first element, that is 1, crossing the first column and the first row. What is remaining? 4, 1, 2, 3 minus the second element, that is 0. Then crossing the first row and the second column, it is 2, 1 and 5, 3 plus third element, that is 3 into crossing the first row and this third column, then 2, 4 and 5, 2. So now we are going to cross multiply here. 1 into 4 into 3 minus 2 into 1 minus 0 into 2 into 3 minus 1 into 5 plus 3 into 2 into 2 minus 5 into 4. So we are written here, and if you go for simplifying it, 1 into 4 into 3, which is equal to 12 minus 2 into 1, which is equal to 2 minus 0 into 2 into 3, which is equal to 6 minus 5 into 1, which is equal to 5 plus 3 into 2 into 2 minus 5 into 4, which is equal to 20. So if you go for simplifying it, this entire term will become 0, and the final result 1 into 10, which is equal to 10 minus 0 into 1, which is equal to 0 minus 3 into 16, that is minus 16. That's why we are putting here minus 48. So if you go for simplifying it, it is equal to minus 38. So minus 38 is the determinant value of a given matrix A. Now we are going to consider various properties of determinant. See, the properties of a determinant is actually refers to the mathematical characteristics and rules that the determinants of a given matrix follows. So these properties actually help us to manipulate the determinant in various ways, making them useful tool in linear algebra and other areas of mathematics. So we are going to consider what are these various properties of determinant. See, the first property, that is one of the fundamental properties of determinant, is that the value of a determinant remain unchanged if its rows and columns are interchanged. That means the determinant of a matrix is equal to the determinant of its transpose. If you are going to interchange the rows into the columns and columns into the rows, and the determinant value of the original matrix and its transpose will be equal. So usually it is refers to the properties of invariance under row or column interchange. So this property we are going to prove. See here, consider one example. Matrix A is equal to 1, 4, 2, 3, 5, 4, 2, 3, 2. Now we are going to find out the determinant value here. Then it is 1 into crossing this concerned row and column, then 5 into 2 minus 3 into 4 minus the second element, that is 4, crossing the second column and the first row, that is 3 into 2 minus 4 into 2, plus the third element 2 into crossing the first row and the third column, it is 3 into 3 minus 5 into 2. So if you go for simplifying it, then it is 1 into 5 into 2, which is equal to 10 minus 4 into 3, which is equal to 12, minus 4 into 3 into 2, which is equal to 6, and minus 4 into 2, which is equal to minus 8, plus 2 into 3 into 3, which is equal to 9, minus 5 into 2, which is equal to minus 10. If you go for simplifying it, then it is 1 into minus 2, minus 4 into minus 2, plus 2 into minus 1, which is equal to 4. So the determinant value of given matrix A is equal to 4. See, now we are going to take the transpose of a matrix A. We are already discussed what actually mean by the transpose. By the transpose, we are going to interchange the rows into the columns and columns into the rows of given matrix. So we are just going to interchange here. Then this matrix A will become, see, 1, 4, 2, it will become the column here. 3, 5, 4, it will become the second column. 2, 3, 2, which will become the third column here. So now after taking the transpose of a given matrix, now we are going to estimate the determinant value of a given matrix. Then see here, 1 into 5 into 2 minus 3 into 4 minus second element, that is 3 into crossing the concerned row and column, 4 into 2 minus 3 into 2, plus third element, that is 2 into, see, concerned row and column is deleted, then it is 4 into 4 minus 5 into 2. If you go for simplifying it, then it is 1 into 5 into 2, which is equal to 10 minus 3 into 4, which is equal to minus 12, minus 3 into 4 into 2, which is equal to 8 minus 3 into 2, which is equal to minus 6, plus 2 into 4 into 4, which is 16, minus 5 into 2, which is equal to minus 10. If you go for simplifying it, then it again, the result is come out with 4. So see here, the determinant of an original matrix is equal to 4, and after taking its transpose, we found again the determinant value is equal to 4. Okay, so we are proved this particular property. Now the second property, that is interchanging any two rows and columns of a matrix will change the sign only, but not the absolute value of the determinant. See, we can say that it is often refers to as it is the sign change under the row or column interchange, or we can also say that it is odd even property of permutations. So here we are going to prove this particular property. See, we are again going to consider the same matrix, and we are going to find the determinant value which we are already found, which is equal to 4. Now we are going to interchanging first row and the second row. First row, that is 1, 4, 2. Now we are going to take this first row into the second row and the second row as first row. See, 3, 5, 4. Now it will become the first row. It became in the second row. So now we are going to find out the determinant value. So if you go for finding the determinant value here, then it again produce here it is 4, but the sign is changed. That is, here it is minus 4. So in this case it was 4. Now it is minus 4. So in this case, that means if you are going to interchange any two rows or columns, then it will change only the sign but not the absolute value. See, now we are going to consider the third property, that is, if any row or columns of a matrix are identical, that means it is linearly dependent, then the value of determinant is equal to 0. That means if column or row are linearly dependent, then the determinant will also be 0. This property actually has many applications of the determinant, such as in determining whether the system of linear equation has a unique solution or not. So if the determinant of a coefficient matrix is 0, then it implies that the system of equation either has no solution or has indefinitely many solutions are there. See, now we are going to prove the third property, that is the matrix A, that is 3, 5, 4, 1, 4, 2, and again the first row is repeated here, that is 3, 5, 4. So as per the property, if we have two similar rows or columns, then the determinant value is equal to 0. So we are going to prove it. See, if you go for finding the determinant value, consider the first element. See, here it is 3 into crossing the first concerned row and column, then it is 4 into 4 minus, it is 5 into 2, minus, considering the second element, that is 5 into crossing the second column and the first row, that is 1 into 4 minus 3 into 2, plus third element, that is 4 into crossing the first row and the third column, then it is 1 into 5 minus 4 into 3. If you go for simplifying it, then the value will be come out with 18 plus 10 minus 28. That means 28 minus 28, which is equal to 0. So if we have the same row or column, see here the first row and the third row is the same or identical, then the determinant value is equal to 0. We are already proved this particular property. Now consider the another property. If each element of a row or column in a determinant is multiplied by same constant, then the value of determinant is multiplied by the same constant. See, mathematically we can say that we have a given matrix A, we have a 3 by 3 matrix here, and we are going to multiply the first row with a scalar or a constant, that is k. So here the first row is multiplied here by using k. Then what is saying here? The result will be equal to, the determinant value is equal to k times determinant of A. K times determinant of A. We are going to prove it by using an example. See, we have a given matrix. We are already calculated the determinant value of this given matrix, which is equal to 4. Now we are going to multiply the first row by using 2. Each element in the first row we are going to multiply by 2. Then it becomes, see, 2 into 1 which is equal to 2, 2 into 4 which is equal to 8, 2 into 2 which is equal to 4. The remaining rows are as it is. Now again we are going to find out the determinant value. So if you go for finding the determinant value here, then see, it is again equal to, it is 8. The determinant value is equal to 8, which means that the determinant value is equal to k times the determinant value of the original matrix. So original matrix value was 4 and we are multiplying with the constant, so it is 2 into 4 which is equal to 8. So the result is came here. So this property is also proved here. That means if we have multiplying any row or column by using any particular constant, then we are also get the same result, that is the constant multiplied by the determinant value of the original matrix. So here it is 2 into 4 which is equal to 8. Now we are going to consider another property, the property number 5. If all the elements of any row or column of a square matrix are 0, then the determinant of that matrix is also 0. See, for example, the matrix A, the first row elements are 0, 0, 0, A21, A22, A23, A31, A32 and A33. Here the first row is 0. Then if you go for calculating the determinant value of the given matrix, then as per the property, it says that the determinant value of this given matrix is equal to 0. We are going to prove it by using an example. See, we have a given matrix A3, 2. Here the second row, each element, all the elements are 0. Then, if you go for finding the determinant value of this given matrix, then see, if you go for simplifying it, then the determinant value is equal to 1 into 0 minus 3 into 0 plus 2 into 0, which is equal to 0. So, we are proved here, that is, if any row or columns, all the elements are 0, then the determinant value is also equal to 0. Now, we are going to consider the sixth property, which is showing that the determinant of a triangular matrix, you know what actually the triangular matrix means, that is matrix with 0 elements either above or below the principal diagonal. Then the determinant value is equal to the product of element on the principal diagonal, which means that, for example, if we have a given matrix A is equal to A11, A12, A13. See here, A11, A22, A33. This is the principal diagonal elements. Below that, all the elements are 0 here. So, this is an example of an upper triangular matrix. So, here you can find the determinant value here. See how we can find the determinant value is equal to, you can just take the product of the element on the principal diagonal. So, it is A11 into A22 into A33. So, it will be equal to the determinant value. So, we are going to prove here, we have a given matrix A. So, here it is a upper triangular matrix. Below the principal diagonal elements, all the elements are 0. So, this is an example of an upper triangular matrix. Now, we are going to find the determinant value here. See, if you go for finding the determinant value as usual, then it is equal to 4. It is equal to 4. Now, there is no need to find out the determinant value in this particular format if we have a triangular matrix. It is nothing but, the determinant value is nothing but here it is the product of the principal diagonal elements. So, here what are the various elements in the principal diagonal? It is 1, 2 and 2. So, if you go for simply multiply here, then it will equal to 1 into 2 into 2, which is equal to 4. So, this is already we are calculated here the determinant value. So, here also we have the determinant value 4. So, we can say that this property says that if you have a triangular matrix, that is either it is upper triangular matrix or the lower triangular matrix, then the determinant value you can find out very easily by taking the product of the elements on the principal diagonal. So, we are concluding here. Today we have discussed how to find the determinant of a matrix and the properties of the determinants, and we validated by using the various examples as well. So, I hope it was clear to you. We will see in the next lecture. Thank you.